transducers. So I hope all of you know what is transducer is about. So transducer is actually a device which convert one form of energy to another form of energy. That is what a transducer. In any measurement system, if you consider any measurement system, the quantity which is need to be measured is a physical variable which need to be measured is the one which first come in contact with the measurement system, right? That is called a detector. A sensor actually going to sense the input signal, physical variable, right? So that is the first part. Then once the measuring instrument which sends the input signal or the physical quantity, then the next stage is to having the conversion. That is transducing, transduction from one form to another form, right? Usually it will be analogous to the digital form, right? So a transducer is a device which will convert one form of energy to another form of energy, and that another form of energy usually it will be a digital signals, right? The electrical output what it going to generate. So that is what the transducer is about. The input for the transducer will be the like a sensor which is going to sense it, right? And the output of the transducer will be the actuator which will supply the signals. Output will going to generate in the form of electrical signals. Usually it will be in the form of electrical signals. You can observe here. So input device will be the microphone, the mic. Here the input will be the voice through that, and the output will be the loudspeaker. It will be enhanced by using the amplifier. Right? The acoustics, the voice is converting into the acoustic. That is the loud, through the loudspeaker. You're going to enhance the signals. So the amplifier will convert from one form to another form. Transducer, right? So microphone, the input signal, it will transduce to usually the acoustics form, the speaker. That is what the transducer is about. Usually these type of transducers, what you want to convert into another for one form to another form, that output what you want to generate, it will be such that it is convenient for the further stages, for the subsequent stages in the measurement system. These electrical signal what it going to generate by the transducer, it will be convenient enough for the subsequent stages in the measurement system to use. So that is what the function of a transducer is about. So in this particular model, half of the model, you're going to discuss about the different types of transducers, right? One form to another form. See that one form of the energy to another form of the energy, what is going to transfer? It can be electrical, it can be mechanical, optical, magnetic, or piezoelectric. From one form to another form, it will go into convert. It will be transforming. That is what the transducer is about. The next topic is transfer efficiency. Transfer efficiency, because it is a transducer, it has to transfer from one form to another form. Transfer efficiency. The transfer efficiency will be given in the form of the ratio, right? That is the output by input. That is the information delivered by the unit. Information delivered by the unit. Information delivered means it is the output. Information output to information input. What the information, what it going to receive will be in the denominator. What it going to deliver, the information, it will be at the numerator. So this is transfer efficiency. Information output to information input. See, usually the transducer, it cannot able to pick up all the, or it cannot be able to generate all the information. So the transfer efficiency, this value, the information output by information input, it cannot be greater than unity, or it cannot be greater than 1. The detector transducer stage, that is the first stage in the measurement system. The first stage is detector transducer stage. That stage must be designed to have the higher transfer efficiency to the maximum extent possible. Then only you can able to enhance the efficiency of the transferring of the information. For the input which is being received, the information what is going to deliver, that efficiency can able to enhance, but it can't be more than unity, more than 1. The detector transducer stage, the first stage in the measurement system, because the measurement system, it consists of 3 stages: detector transducer stage, intermediate modifying stage, the third one is terminating stage. In this one, the first one is the detector transducer stage, right? That stage must be designed to have higher transfer efficiency in order to transmit the information to the maximum extent possible, right? So that is what transfer efficiency. So next topic is primary and secondary transducer, right? So we already discussed about this board on tube pressure gauge, right? You can observe over that the board on tube pressure gauge. In the previous class also we discussed about this board on tube pressure gauge. The purpose of this is to measure the pressure of the fluids, or it can be the air, or it can be the any fluids, right, or liquid. Board on tube pressure gauge. So this topic, particular primary and secondary transducer, we're discussing with respect to the example of the board on tube pressure gauge. You can observe the animation on the right side. As the pressure of the air increases, how the board on tube pressure gauge, the pointer will be moving on the scale. Right? See these pressure input. This is the board on tube, which is flexible tube, which will tend to complete, which will tend to deform, right? And these will be the gearing and pinion mechanism, and this will be the link, right? So as soon as the pressure of air enter into this board on tube, flexible tube, it tend to deform, expand. So because of that, it pushes the link to which the gear as well as the pinion is being attached, it tend to move. Thereby the pointer will be rotating on the scale. Thereby you can able to measure the amount of pressure which it can able to sense it, right? So here also it is a transducer from one form to another form, primary and secondary transducer. So you can observe this, the flow diagram of it. So input signal, that will be in the form of pressure, right? Input signal, it will be the pressure. The primary transducer here, it is the board on tube. You can observe in the screen over here, right? The primary transducer will be the board on tube, because primary means the initial one, which is going to sense the input signal primarily. And in this example, board on tube pressure gauge, it is the board on tube is the one which senses the input signal, right? So here board on tube acts as the primary transducer. One more here, secondary transducer. The LVDT, what you can able to see over here, here in this example, board on tube, which is connected to the LVDT, linear variable differential transducer. This acts as the secondary transducer. So finally the output will be the voltage. The board on tube pressure gauge, it actually measures the pressure, right? If this board on tube, if it is connected to a separate attachment like this LVDT, So all of you know this one, right? Linear variable differential transducer. It is a passive transducer. All of you know that, right? So the core of this, which has been connected to through a cord to the board-on tube. So as soon as the pressure is being inserted into this board-on tube, which is a flexible tube, which will tend to deform, and the cord which is connected to this particular core of the LVDT, it will tend to move because of this movement of the core. So whether it is the moving from the null position to maximum right or maximum left, there will be a voltage difference, right? That voltage difference can be used to measure. That is what LVDT. So suppose if this LVDT is connected to this board-on tube, the entire board-on tube itself will act as the primary transducer, which will sense the input signal. And finally, the sensing of this signal, the displacement of the board-on tube will become the input for the LVDT, because the board-on tube is moving. So the cord is connected to this LVDT. That displacement of this will make the LVDT to generate the voltage. You can observe here output voltage. So primary transducer in this example, it is a board-on tube. Secondary transducer is LVDT. Right? See, primary transducer, secondary transducer means primary transducer is the one which convert one form to transducer is the one which convert one form to another form. So primarily the pressure is converting into displacement from one form of energy to another form of energy is converting by this board-on tube. There is the one form of conversion primarily. But secondary transducer, as the name represent, whatever the transduction which is being happen, the displacement. So the displacement of this board-on tube will become the input signal for the LVDT. So finally, it will convert that into a voltage. So again, energy conversion. See here, displacement of the board-on tube, it is one form of energy, is converting into the voltage, another form. So that is done by this LVDT, which acts as the secondary transducer. That is the second transducer means the second time it is going to do the conversion. So whatever the output which you are going to receive from the first or the primary transducer will become the input, and that input is converting into another form. So primary, secondary transducer. So the next topic is active and passive transducer. You can observe active transducer, the image. The another name of this active transducer is also called as self-generating type transducer. Self-generating type, as the name represents, self-generating, that's why it is active. These type of transducer devices which can generate the power through which they can able to generate the output signal. It does not rely on the output, or it does not rely on the external source of power supply. Right? Auxiliary power source is not required for these type of transducers. That's why it is called active, or it is also called self-generating type transducer. They develop their own voltage or the current. That is, this system itself can able to generate the required voltage or the current through which it can able to generate the output signal. It does not require auxiliary power source. That type of transducer is called active transducer. And the example of this active transducer is thermocouple. So this is again another experiment in the M lab. We will going to have thermocouple, right? So the difference between thermocouple and thermometer. See, thermometer is actually used to measure the temperature only, right? It is used to measure the temperature. Whereas thermocouple is the one which it can able to generate the small EMF, electromotive force, or the voltage, through which it can able to measure the temperature. The generally thermocouple, it consists of two different metals. You can observe in this image over here, right? This is one metal, the blue color one. This is the another metal, red color one, right? Both are at the one junction, connected to one junction. Two different metals connected to at one junction. This is the cold junction. This is the hot junction. Whenever this thermocouple will be heated at the hot junction, there will be a voltage induced, and that is the EMF. A small voltage can be generated by the thermocouple, which is not there in the thermometer. That is the difference. A thermometer can able to sense only the temperature, whereas a thermocouple is an electrical device consists of two dissimilar metals, right? Two dissimilar, we can able to see wire type A, type B, two dissimilar metals, that is the electrical conductors. A thermocouple produces a temperature dependent voltage, it is EMF, as a result of the thermoelectric effect, right? So these are actually a widely used sensors, thermocouple sensors, right? So this is the one example of active transducer. Or if you take another example, photovoltaic cells, or you can call it as the solar panels or solar cells, that is a active transducer. Like in the solar panel or solar cells, it does not require auxiliary power source. It generates the power by itself, active. It does not rely on the auxiliary power source. It is considered as active transducer, right? You can observe here the thermocouple, right? The thermocouple, it works basically on the Seebeck effect, right? You can observe here, this is the Seebeck effect. That means a Seebeck effect means it is a phenomenon in which the temperature difference between the two dissimilar electrical conductors or semiconductor produces a potential difference. Whenever a potential difference arises at the junction, it generates a small voltage, that is called EMF, electromotive force. Through that small voltage, you can able to measure the temperature also, right? That is the thermocouple. Basically, the thermocouple, it actually acts as a sensor. Most of the engineering application, it uses as a sensors, thermocouples. There are different varieties of thermocouples. Based on the application, based on the requirement, they go to select that type of thermocouple. These type of thermocouple, it will be inserted into the elements for which the experiment what they want to perform. So whatever the temperature variation will be there, at a higher accuracy, it can able to sense. Usually, these type of, if you take thermometer, it is restricted only for the lower temperatures, right? Around 100 or 120 or 130 in that range only, thermometer to measure the temperature. Whereas the thermocouple, basically it is used for measuring for the high temperatures, even for the metals. It can able to sense the temperature for the certain metals, but which is not possible by the thermometer, right? It works based upon the effect that is the Seebeck effect. You can observe here, when a pair of dissimilar metals are joined at one end, here like this, metal A, metal B, there is a temperature difference between the join end and the open end. This is the open end, this is the join end. Whenever this junction, there is a hot junction, whenever it is going to get heated, and whenever this open junction is being at the cool point, so it will going to generate, there is the potential difference will going to arises. So because of that, it will generate a small voltage, which is in the form of the EMF, electromotive force. A small voltage will be generated. So that voltage can be used to measure the temperature. You can observe this graph also, the variation of thermo EFF with the temperature difference. As a temperature difference, electromotive force, how it going to increases. Right? So there is the thermocouple, which is an example of active transducer, or it is also called self-generating or self-powered transducers. It does not require auxiliary power source, photovoltaic cell, thermocouples. The input signal, it generates the output signal. See, now you can observe here passive transducer, the same image, but here there is the auxiliary power source is there. As compared to the previous one, here active transducer, there is no auxiliary power source. External power source is not being mentioned here. Whereas in this passive transducer, auxiliary power source. That's what is called passive. That means this won't able to generate the power by itself. That is, it does not have the capability to produce the output signal by generating the power by itself. So those are called passive transducers, or it is also called as external powered type transducer, because it uses the auxiliary power source. Without this external power source, it won't able to generate the output signals. Those type of transducer are considered as passive transducers. The examples, the LVDT, linear variable differential transducer, what we discussed earlier also, right? That is an example for passive transducer. Some of the resistiveness, that is also considered as the passive transducer. You can observe here this mic, it is a passive transducer. Without supplying the power, auxiliary power, it won't able to generate the acoustics, the sound. That's why it is also a passive transducer. You can observe over here some other examples of the transducers. This is called piezoelectric transducer, right? You have learned this piezoelectric transducer in the material science also, MS also, right? Piezoelectric. Piezo represent, it is the pressure. Because of the application of the pressure, piezoelectric transducer. Piezoelectric. Piezo means pressure, electric means electric charge. That pressure is converting into electric charge. That's why it is called piezoelectric transducer. What you are observing, both are piezoelectric elements. Piezoelectric is actually a material. Piezoelectric materials. These type of materials possess a unique property that whenever you apply a pressure, it will generate a small electric charge. That's why it is called piezoelectric. Piezo means pressure, electric means the electric charge it can able to generate. So this example, what you are seeing, is it an active transducer or passive transducer? It is active transducer. Right? All of you can able to observe it is active transducer. There is no auxiliary power source. You can observe here also. You can observe here also. The both example. Right? Only we are applying the pressure. You can observe here. This is the piezoelectric material. See the cursor. You are applying the pressure. Because of this compression and expansion, the property of that material itself is such that it can able to generate the electric charge. This is piezoelectric materials. This is also an example of an active transducers. Usually these type of piezoelectric material, even it can be used in the automobiles also to identify the the machine the engine ignitions also, right? Piezoelectric transducer or active transducer. It has the capability to generate the output signal by itself. Usually electrical signals, right? Active transducer. So this is an example of passive transducer, as I said here, right? So here LVDT, it is passive transducer. That means it is also called externally powered type transducer. it requires auxiliary power source. LVDT, linear variable differential transducer or transformer, which convert mechanical displacement of the core into electrical signals. It is also called electromechanical transducer. Combination electromechanical transducer. Mechanical movement of this core is converting into electrical signals. That's why another name is electromechanical transducers. This we already discussed in the previous topics, right? The same image I have shown that one, right? The core primary coil will be there, secondary coils will be there. Secondary coil 1, secondary coil 2. The null position, maximum left, maximum right. So the output voltage, what it going to generate. So it is electromechanical transducer. See, in this example, what you are observing, it is not just the mechanical movement of the core. In order to make this core is actually, it is a magnetic material, right? So whenever, in order to make the core to lift in the air, so this is the in the in this particular hole, if the core has to be moved freely in the left position or in the right position, this core has to be lifted, and that lifting will be done by supplying the power, the DC power, through this primary winding. Without supplying the power through this primary winding, it is not possible for the core to lift. If it is not possible for the core to lift, it won't be able to move freely like this, left or right position. So in order to make this to lift, the auxiliary power source is required. The DC power source is required. So if it require auxiliary power source for the functioning of this, then it is considered to be as the passive transducer or externally powered type transducer. Without supplying the DC power source for this primary coil, this core won't be lifted in the air, the space, so that it can able to easily freely move from left to right to in order to generate the electrical signals. This is also there in the Triple lab, the experiment LVDT, calibration of LVDT. So this is about the passive transducer. It requires auxiliary power source. It is a passive transducer. So mechanical force is converting into electrical signal. That's what is called transducer. See the comparison between these two, the active and the passive transducer. The active, as already we discussed, the transducer will generate the output in the form of a voltage or the passive transducer whose internal parameter like capacitor, resistance and inductance changes because of the input signal. That means input signal, you have to supply the auxiliary power source for it. Otherwise, it won't possible for the passive transducer to generate the signals, output signals. See here, additional energy source not required for active, whereas for passive it is required. The working principle of this active transducer, draw energy from measurement source. It draws the energy from the measurement source itself. Whereas here, it take power from external source, which changes the physical property of a transducer. The input itself, that is the measurement itself, will be the source of energy for it. Whereas here, it is not like that. Apart from input signal, it also required some sort of external power in order to function. That is what passive. So these design will be simple. For active transducer, the design was simple, whereas passive transducer is a little bit complicated. The resolution is low for this, resolution is high because it uses the auxiliary power source. Again, the output signal for active transducer produces from the signal to be measured. Whereas here, output obtains by receiving a signal from the external power source. The examples for active transducer, thermocouple, what we discussed, active transducer, right? Photovoltaic cell, taco generator, those are the examples of active transducer. Even the thermocouple also, it is active transducer, right? It does not require auxiliary power source. By the normal temperature, normal heat itself, it can able to generate the EMF thermocouple. Whereas passive transducer, observe here, differential transformer, that is the LVDT, photomultiplier tube, or the thermistors. These can't function without the auxiliary power source. So these are the examples of passive transducer. So active and passive transducer. So next topic will be electrical transducer. So as the name represent, electrical transducer, right? See, the majority of the measuring system, the mechanical member are actually serve as a detector transducers. That is the first stage. And the output, what it's going to generate, will be in the form of electrical elements, right? And usually these type of electrical transducer, it actually acts as the secondary transducer rather than primary transducer. Most of the measuring system, the mechanical elements or mechanical sensor acts as the primary transducer, which can sense the input signal and it will convert that input signal into some form. Whereas the electrical transducers are the one which acts as a secondary transducer. Whatever the input signal which is being sensed by the primary transducer, the output of that will become the input for these type of transducer, electrical transducer. It basically serves as secondary transducer. So whatever the displacement, what it going to generate by the first transducer, that is the primary transducer, that will converting into some electrical quantity, which is in the form of voltage or current. Those are called electrical transducer. See the previous example, what we discussed about that quadrant tube pressure gauge, you can observe here, right? Electrical transducer, right? That will be the LVDT. It is acts as the secondary transducer. The primary transducer is Bourdon tube. The Bourdon tube is actually a mechanical element, right? Once the pressure is being sensed by this, it will convert into displacement. But this displacement is the input for this electrical transducer, which can generate the voltage or the current. So usually the electrical transducer will act as the secondary transducer rather than as the primary transducer. So that is what I try to explain over here in the electrical transducer. Right? See some of the different types of electrical transducers. If it is the sound, it is electrical microphones. If it is force, it is the load cell. Load cell experiment, I think we already done that one in the curriculum lab, calibration of the load cell. The electrical signal, what is going to generate. If it is a thermal, it is the thermocouple, electrical, right? If it is the light, it is the solar panels. The electrical transducer is the one, it is a device which convert energy of any kind into electrical signal. Any sort of energies, any sort of the energy is converting finally into electrical output. Right? It can be analog or it can be digital, but it's some sort of electrical signal, but it can able to generate. Those are called electric transducers, electrical transducers. See here, an electrical transducer is the one which can convert a non-electrical quantity into an electrical quantities. The non-electrical quantity into electrical quantity. Non-electrical quantity means the displacement or even the force, the temperature or the stress. All these non-electrical quantity into electrical quantity. That conversion is done by this electrical transducers. The electrical quantity means the current or the voltage. So this is one example that is being shown over here with the application of the LVDT, an electrical transducer. Basically, LVDT is a electromechanical transducer, but it comes under the transducer of the electrical because it finally generates the electrical output. Any form of energy is converting into electrical output, current or voltage, which can be analogous or digital. Those are electrical transducer. So using this LVDT with a float. So this is the water tank which is filled with the fluid. If the float is connected to the core of the LVDT, as it moves up and down, the core will move. Finally, it's going to generate the output signal in the form of voltage variation or the current, which will sense the presence of the level of fluid. So an electrical transducer. So next topic will be capacitive transducers. As the name represents, capacitive. It uses the capacitance. It basically works on the capacitance. It uses the capacitors, right? See, the principle of this type of transducer is based on the variation in the capacitance. That variation in the capacitance is used for the measurement of the physical phenomena, whether it can be force, displacement, whether it can be pressure. All those physical phenomena can be measured using these type of transducer, capacitive transducer, by based on the principle of variation in the capacitance. That's what it is called, capacitive transducer. Electrical transducer, it works based on the electrical output, whereas here in this it works based on the principle of variation in the capacitance, which is used to measure the physical phenomena like pressure, displacement, force, or any other physical phenomena or parameters. So there is capacitive transducer. The capacitance, it works basically on the variation in the capacitance. The capacitance means, or a capacitor is a device which can able to store the electric charge. So all of you know that one, right? Capacitor is the one which can able to store the electric charge. It will hold the electric charge in it. That means it can able to, it is a measure of the amount of electric charge stored in it for the given electric potential. So this is what you are observing on the screen. It is a capacitor. See, these are different capacitors, right? With different voltage potential, which can be, you might have seen in the electronic circuits or electron boards, these type of capacitors, right? So basically, these type of capacitors, by varying the capacitance, it can able to sense the input phenomena, physical phenomena, like pressure, displacement, force, or any other, right? See here, usually it will going to store the power, that is the current, charge. So this is the equation of capacitance. Right? The capacitance, the variation in the capacitance can be measured with this equation. The K is the dielectric constant. If the dielectric medium, if it is air, it will be equal to 1. Dielectric medium, right? A will be the area of one side of the one plate. This I will explain again in the next slide about this capacitor. Right? N will be number of plates. D will be the separation of the plate surface, the distance between two. Here, this is the basic concept of a capacitive sensor. Usually, what the capacitor, what you have seen over here, these type of capacitor, right? It actually this right. This usually it consists of the two plates, two flat plates. You can observe here. It consists of two flat plates, which is not in contact, which is separated by a certain medium. Either it can be paper or it can be air. Some dielectric medium it will be there in between. Two plates, flat plates will be there inside this capacitor like this. You can observe, right? This is plate 1, plate 2. Both are having the different charges. See, basically capacitor here, this is a simple passive device. It is a passive one. It is not active. It requires external power source. It is a passive device. It can store the electric charge. Basically, it's going to store the electric charge means it stores the electric charge on the plates. What you are observing on the plate when it is connected to some voltage source, external power source. It actually stores the current on these plates only. This capacitor consists of these type of plate, two plates, which is separated by a dielectric medium in between. The capacitance is nothing but the capability or capacity to store the charge, that is called capacitance. So these type of capacitive transducer works basically based on the principle of variation in the capacitance. So variation in the capacitance means variation in the charge which is going to store in these plates. So that is what the variation in the capacitance. See, consider this example here, right? Or this example, two plates which is separated by dielectric medium. So here, assume there is a dielectric liquid, here dielectric air. Some sort of medium will be there in between the two plates. So these are the basic capacitive circuit. Right? See, when the capacitance plates are connected to a battery, right? The electron on the plate 2 are attracted to the positive side of the battery. You can observe here, right? While the electron on the plate 1 are repelled by its negative side. So that is how the charge accumulation will take place. That is how the capacitor can able to store the charge in it. Basically, it is a charge carrying conductors. Can able to store the electric charge in it. See, this causes a flow of the electron until the battery potential is developed across the capacitor. The larger the capacitance, more current will flow to charge it. Lesser the one, lesser the current flows through it. So based on the amount of the charge what is going to flow through it, the current flow, the capacitance, whether it is bigger one or the smaller one, they're going to consider based on the amount of current what is going to store. That's why here we'll be having different sizes of the capacitors. See, the capacitive transducer can be used in the three uh, three variations or in the three methods of application of this capacitive transducer. See here, what you are seeing here, capacitive transducer by using the changing dielectric constant. Using the capacitive transducer by changing the dielectric constant for the measurement purpose. There is the one method. There are other two methods are also there. Capacitive transducer by varying the dielectric constant, by changing the dielectric constant. Right? Capacitive transducer. You can observe here in this image, right? The variation in the capacitance can be observed at this point. Right? This liquid, what you are observing in this tank, this is the dielectric medium. dielectric medium, it can be liquid also, it can be air also, right? You can observe in this animation also here, right? This is the one example of application of the capacitive transducer to measure the level of water in the tank. The level of water, whether it is high or low, whether it is more or less, that variation in the level of water can be measured by using the capacitive transducer. That is by changing dielectric constant for the liquid. You can observe here also in this animation, it consists of two plates. Here also, right? And that variation is measured as a measurement in the variation in the capacitance. This is an example of the measurement of the level of liquid in the tank. Here, this figure shows a device which is used to measurement of the level of liquid in the container. The capacitance between the central electrode, what you are observing here, this is central electrode, and the surrounding hollow tube. This is the hollow tube. Inside this hollow tube, one more tube, which will be in the form of the electrode, the central electrode, like a rod. The capacitance between the central electrode and the surrounding hollow tube, like two plates. You can observe here two plates. The capacitance between this is consider this as one plate and this as the another plate. The capacitance between the central electrode and this surrounding hollow tube varies by changing the dielectric constant. That change in the dielectric constant is going to happen because of change in the level of liquid in the container. As the level of liquid in the container varies, the dielectric constant will going to be vary, and because of that the capacitance will going to vary, and this is the indication that the level of liquid in the water in the container, whether it is more or less. So that is one of the way in which this capacitive transducer can be able to use. The variation in the dielectric can also be utilized for measurement of the thickness also as well as the density also. In this example, I will explain again here by considering this one example here. So this is actually an article, a research article, which is being published in 2019 in the Springer. Actually, a project, it is being designed and developed by these people. You can observe here on the screen, right? Practically, they have done this experiment by how to use the capacitive transducer to measure the level of water or the fluid in the container. You can observe the title also here, the research article, Design, Development and Application of Real-Time Capacitive Sensor. See, capacitive transducer or capacitive sensor, both are same. Most of the time, the transducer is also considered to be as or also called as sensor, because a sensor is the one which senses the input signal and generate the output from one form to another form. That is exactly what the transducer also will does. It convert one form of energy to another form. So capacitive transducer or capacitive sensor, both are the same. You can observe here in the article title, Design, Development and Application of Real-Time Capacitive Sensor for automatically measuring the level of liquid. So automatically it will going to measure the level of liquid contained in this container. This is the article, an experiment which has been done. See, basically here you can observe in this image, right, two plates you can observe here, right, positive, negative. It is being separated by a dielectric medium. So here it is a fluid. So inlet from the pump, the water is going to enter over here, and this is the control circuit, and finally the LCD will going to display the amount of liquid or amount of water in the container in the form of the voltage output, because it basically work based on the variation in the capacitance. Variation in the capacitance means variation in the voltage. You can observe here the real-time capacitive sensor mounted on tank side. Audit operation principle of proposed model with dielectric liquid. So this experiment they have conducted like this. You can observe on the screen, right? This is the one. They took this PVC tank, they filled with the water, and these are the sensor, capacitive sensor, or you can call it as the capacitive transducer, which is being separated by a dielectric medium. This is being placed over here in the tank. As the level of water or the liquid varies, the dielectric constant will going to vary. Because of that, the capacitance will vary and it will indicate in the form of voltage, output voltage. You can observe this table over here. See this cursor. See performance of the proposed real-time liquid level capacitive sensor. See height of the water, the level of water in the tank, right? The output voltage. See here the readings. If the height of the water, that is the level of water in the tank, if it is 0, then it will be 1.58. That is the voltage what we want to show. Suppose if it is 0.95, it will indicate that is the level of water will be at the maximum. That is the meaning here. See, as the voltage variation, it will indicate the level of water in terms of millimeter in the tank. That is what the experiment they have conducted. See, by they use the voltmeter, which will indicate the voltage, because it works basically on the variation in the capacitance. That variation in the capacitance works because of the variation in the dielectric constant, and that depends on the level of water, level of liquid. Here the voltmeter indicate an output voltage of 1.58 volt with the empty tank. You can observe here 0, 1.58. It was observed the output voltage variation from sensor submersion in the tank loaded with water. The output voltage value was 0.95 volt. Here 0.95 volt with full fill tank. The tank is fully filled with the water, then it will show the voltage as 0.95. By using the voltmeter, they can able to sense it. By this, they can able to estimate the level of water in the tank, whether it is half, whether it is full, whether it is empty. Right? So there was a voltage values variation obtained at output of the circuit from water level height variation. There is the table 1. This is the table 1, what it shows. The measurement realized directly on the tank in terms of millimeter. And these are the respective voltage what they have obtained by the capacitive level sensor. These variation, it is because of the capacitance value, which is going to increase or decrease, right? Basically on the dielectric medium what it is being used, right? So this is an actual experiment which is being conducted, and this is the publication which is being published by using the capacitive sensor to automatically detect the presence of level of water in the tank. Right? So that is what one of the application of capacitive transducer, by one of the method in which you can able to use the capacitive transducer by changing the dielectric constant. There are three methods of using the capacitive transducer. In that, one of the method is just changing dielectric constant. Because of this, the capacitance vary and the voltage will vary like this. By this, you can able to measure the level of water in the tank. So this is the article, a journal which is being published based on the experiment what these people have done. design, development, and application of real-time capacitive sensing.